Right now, you're sitting on a planet that orbits a star. That star is one island of light in a darkness so vast that if you could see it clearly, you would never feel safe again. Most people imagine the darkness of space as a simple backdrop, a black canvas behind the stars. It is not. The darkness of space is structural. It is the visible proof that almost everything in the universe exists outside the tiny zones of light and warmth where life is even possible. The deeper you travel from home, the worse it gets. Not just darker, emptier, more separated, more permanent. Tonight we're going to cross every scale of that darkness, from the shadow behind the moon to voids so large they contain almost nothing at all. If this kind of science keeps you thinking, a like and subscribe genuinely helps this channel reach more people who care about understanding the universe. Are you comfortable? Let's begin. Go outside tonight. Find a clear patch of sky, away from streetlights, away from buildings, and look up. What you will see is one of the most convincing illusions in all of nature. Stars everywhere. Thousands of them, scattered from horizon to horizon, bright and faint, clustered in some places, thinned in others, and underneath them all, the soft, glowing river of the Milky Way stretching across the sky like a road made of light. It feels full. The sky feels populated. Your brain, without being asked, draws connections between those points of light. It groups them into shapes, into constellations, into patterns that suggest proximity and order. The sky looks like a canopy stitched with lanterns, a ceiling covered in bright, close, familiar things. Every one of those impressions is wrong. The stars you're looking at are not close together. They are not forming the patterns your brain imposes on them. They are not even at the same distance from you. The constellation Orion, one of the most recognizable shapes in the sky, is not a real structure. It is a trick of projection. The star at Orion's left shoulder sits roughly 650 light years from Earth. The star at his right knee sits roughly 860 light years away. The stars between them are scattered at unrelated distances, none physically connected to one another in any way. The shape you see is like looking at 5 birds flying at 5 different altitudes and deciding they form a circle because they line up from where you happen to be standing. This matters because the sky is the only evidence your senses ever give you about the universe's structure. And that evidence is profoundly misleading. The night sky makes space look dense. It makes the universe look full. It makes you feel like the darkness between stars is a thin gap, a little shadow between bright neighbors. That feeling is the beginning of the misunderstanding this entire story is built around. The total number of stars visible to the unaided human eye under perfect conditions, with fully dark adapted vision and no light pollution and no atmospheric haze, is roughly 5,600. That number sounds large until you compare it to what actually exists. The Milky Way alone contains somewhere between 200 billion and 400 billion stars. You are seeing roughly 1 out of every 40 million. And the stars you do see are almost all local. The vast majority of visible naked eye stars are within about 1,000 light years of the solar system. The Milky Way disk is approximately 100,000 light years across. You are seeing a sample from the nearest 1% of the galaxy's diameter and treating it as a representative picture of the whole. The picture it gives you is not representative. It is the cosmic equivalent of standing in a crowded elevator and concluding that the entire building must be packed wall to wall with people, when in reality the rest of the building is empty. Here is where the darkness starts to reveal its first layer of meaning. It is not simply that the sky is black between the stars, it is that the blackness represents something physical. Every dark patch you see when you look up is a direction in which no star is close enough and bright enough to register on your retinas. That dark patch is not a gap in a wall. It is a corridor of emptiness extending outward for distances your mind cannot meaningfully process. Passing nothing, touching nothing, carrying nothing but faint traces of radiation for billions of light years in some cases, before terminating at the edge of the observable universe. The darkness between two visible stars is not a shadow. It is a chasm. And the fact that your brain does not instinctively interpret it that way is not a failure of intelligence. It is a consequence of evolution. The human visual system was forged over millions of years in environments where darkness meant shade, night, or the inside of a cave. Darkness was always local. It was always temporary. The sun would rise. The fire would be relit. Something bright was always nearby. The human brain was never asked to process the idea of a darkness that extends for trillions of kilometers in every direction and contains nothing at all. When it encounters that idea through a telescope or a photograph or a description like this one, it has no intuitive category for it. So it files it under the closest thing it knows: night. Just a bigger, emptier version of night. That substitution is where most people stop, and it is exactly where the real story begins. There is a puzzle in physics that was first asked over 400 years ago. It has a name. It's called Olbers's paradox. The question sounds almost childishly simple. If the universe is filled with stars, why is the night sky dark? Think about what the question is really asking. If you imagine a universe that is infinitely large and infinitely old, filled uniformly with stars in every direction, then every line of sight, no matter where you point your eyes, should eventually end at the surface of a star. Not just some directions, every direction. The sky should not have dark patches at all. It should be a blinding wall of light in all directions. Every square inch of the sky filled with the surface brightness of a star. The night would never be dark. The sky would glow like the inside of a furnace. It does not. The sky is overwhelmingly dark. And that simple observation tells you something enormous about the universe you live in. The resolution of Olbers's paradox comes from two facts that are among the most important in all of cosmology. The first is that the universe is not infinitely old, it has an age. Current measurements place the age of the observable universe at approximately 13.8 billion years. That means light has had a finite amount of time to travel. Stars that exist beyond a certain distance have not had enough time for their light to reach you, even traveling at 300,000 kilometers per second since the moment they first ignited. There is a boundary, a cosmological horizon, beyond which no signal has had time to arrive. You are not seeing an infinite number of stars. You are seeing only the ones whose light has physically had time to reach your position. The second fact is that the universe is expanding. Space itself is stretching, and as it stretches, the light traveling through it stretches too. A photon emitted as visible blue light by a distant galaxy billions of years ago has had its wavelength pulled longer and longer during its journey, shifting from blue to red, from red to infrared, from infrared to microwave, from microwave to radio. The further the source, the more the light is stretched. The more it is stretched, the less energy it carries. The less energy it carries, the dimmer it becomes to any instrument tuned to visible wavelengths. This is not a metaphor. This is the measured behavior of photons crossing an expanding universe. It is called cosmological redshift, and it is one of the most precisely confirmed phenomena in all of modern physics. Light from the most distant observable sources has been redshifted so far that it has left the visible spectrum entirely. It still exists. It still fills the sky, but it has been stretched beyond the range of human eyesight. This leads to one of the most extraordinary facts about darkness that almost no one outside of astrophysics ever encounters. The sky is not truly dark. Not if you could see all wavelengths. In every direction, in every single patch of sky with no exception, there is a faint glow. It is the cosmic microwave background, the remnant radiation from a moment approximately 380,000 years after the beginning of the universe, when the cosmos cooled enough for atoms to form and light to travel freely for the first time. That light has been traveling ever since. It fills all of space. It comes from every direction, and it has been redshifted so far by the expansion of the universe that it now registers as microwave radiation with an effective temperature of approximately 2.7 degrees above absolute zero. If your eyes could see microwaves, the sky would glow everywhere. There would be no darkness at all. The entire dome of the sky would shimmer faintly, uniformly, in every direction. You would see the afterglow of creation itself, still radiating, still washing through space, 13.8 billion years after the moment that produced it. The darkness you perceive when you look up at night is, in part, a limitation of the detector you are using. Your eyes respond to a narrow band of the electromagnetic spectrum, a sliver of wavelengths between roughly 380 and 700 nanometers. The universe radiates across a spectrum billions of times wider. The overwhelming majority of the light in the cosmos is invisible to you, not because it does not exist, because your biology was never designed to see it. This fact alone should reshape how you think about the dark sky. The darkness is not a pure absence. It is selective blindness. The universe is full of radiation you cannot perceive, and the radiation you can perceive, visible light, represents only the output of objects close enough and hot enough to shine in that narrow band. Everything else, every signal that has been redshifted out of range, every photon emitted in wavelengths your cones and rods ignore, every source too faint to trigger a neural response, all of it registers as black, as nothing, as the same empty darkness that your ancestors saw when they looked at the back wall of a cave. There's a detail about our neighborhood that makes the local darkness even more thorough than it would be elsewhere in the galaxy. It was not well understood until relatively recently, and most people have never heard of it. The solar system sits inside a structure called the local bubble. Roughly 15 million years ago, a series of supernova explosions ripped through the region of the galaxy where our solar system now resides. Those explosions were powerful enough to sweep the surrounding interstellar gas outward in every direction, clearing a cavity in the galactic medium roughly 1,000 light years across. The gas that would normally fill interstellar space in this region was pushed to the edges, compressed into a shell, and left behind a volume of space that is significantly emptier than the galactic average. The local bubble is not a perfect vacuum. It still contains traces of hot, thin gas, but its density is roughly 1/10 that of the typical interstellar medium in the galactic disk. The space between stars in our neighborhood is already one of the emptiest natural environments that exists. The local bubble makes it emptier still. We are not just living in the dark between stars. We are living in a pocket of the dark that is unusually hollow, a cavity blown clean by ancient stellar explosions that scattered the material that would otherwise have softened the void around us. This has measurable consequences. The interstellar medium, thin as it is, does interact with light. Dust grains scatter and absorb photons. Gas clouds emit faint radiation. In regions with denser interstellar material, the space between stars has a faint, ghostly presence, not enough to see with the naked eye, but enough to detect with instruments. Inside the local bubble, even that faint presence is reduced. The space around our solar system is more transparent, more empty, more dark than the average galactic neighborhood. It also means that the star-forming regions nearest to us, the clouds of cold gas where new stars are being born, are pushed to the edges of the bubble. The walls of the local bubble are where much of the nearby star formation is happening. We sit in the cleared interior, surrounded by a shell of activity but separated from it by hundreds of light years of unusually clean void. The fact that humanity's home sits inside this ancient blast cavity is a coincidence of timing and trajectory. The sun has drifted through the galaxy on its orbital path and happens to currently reside within the bubble. In a few million years, it will move beyond the bubble's boundary and into denser interstellar material. But for now, the darkness between us and our nearest stellar neighbors is even more thorough than it would be in a typical stretch of the Milky Way. The emptiness around us is not average. It is below average. We are surrounded by a darkness that is unusually dark, even by the standards of a galaxy that is already almost entirely void. And we did not know this until astronomers mapped the three-dimensional structure of the local interstellar medium in detail, a process that has accelerated only in the last 2 decades with improved survey data. For most of human history, we had no idea that the space around us was a blown-out cavity. We looked at the darkness between the stars and assumed it was representative. It was not. It was emptier than normal. The universe was even darker than it looked. But here is the critical distinction. In a cave, the darkness means there is a wall nearby blocking the light. In space, the darkness means there is nothing nearby at all. Now let us talk about what the night sky hides from you through sheer geometry. When you look at the Milky Way on a clear night, that band of light appears thick and bright. It looks like the galaxy is dense with stars, packed tightly, glowing with combined light. And on the scale of naked eye impressions, that is roughly accurate. You are looking through the plane of the galaxy's disk, and the accumulated glow of billions of distant stars blends together into that river of light. But the density is an illusion of depth, not proximity. You are looking through tens of thousands of light years of galactic disk. The light you see is the sum of stars spread across an enormous distance, stacked behind one another like street lights on a highway that extends to the horizon. They look close together because you are seeing them end on, compressed by perspective into what appears to be a thick band. In reality, each of those stars is separated from its nearest neighbor by a distance so large that no human vehicle has ever crossed even a tiny fraction of it. 5 light years. That number does not communicate anything to a human brain without translation. 5 light years is approximately 47 trillion kilometers. If you could drive a car at highway speed without stopping, it would take you roughly 54 million years to cross the average gap between 2 neighboring stars. And that is just the average gap between neighboring stars within a galaxy that is considered rich with them. Each star occupies a point. The space between those points is, for all practical purposes, empty, not thinly populated, not sparse, empty. The interstellar medium, the material that fills the space between stars across the galactic disk, has an average density of roughly 1 atom per cubic centimeter. For comparison, the air you are breathing right now contains approximately 25 quintillion molecules per cubic centimeter. The interstellar medium is a vacuum so thorough that no laboratory on Earth has ever achieved it. And this vacuum is not the exception. It is the rule. Stars are the exception. Stars are vanishingly rare concentrations of matter in a medium that is defined by the absence of nearly everything. When you look at the night sky and see stars, you are seeing the anomalies. The background state of the galaxy, the default condition of interstellar space, is the darkness between them. That darkness is not a gap in the light. It is what the galaxy actually is. The stars are interruptions. This is the first major correction to human intuition about cosmic darkness. People imagine space as a dark room with objects in it. That framing puts the objects first and treats the darkness as secondary, as the backdrop, as the container. The reality is inverted. The darkness is the primary substance. The objects are scattered through it so thinly that they occupy a fraction of the volume so small it is difficult to express with words. Consider this. If you took all the stars in the Milky Way, all 200 to 400 billion of them, and spread their material evenly across the galaxy's volume, the resulting density would still be a near-perfect vacuum by any human standard. Stars are not small. Many of them are millions of kilometers in diameter, but the spaces between them are so overwhelmingly larger that the stars collectively account for a negligible fraction of the galaxy's volume. You live in a galaxy, and your galaxy is almost entirely empty. That emptiness is not the cosmic background radiation. It is not dark matter or dark energy. It's literal, measurable, physical emptiness. Volumes of space containing nothing but scattered atoms, and the occasional photon passing through on its way from somewhere unimaginably far to somewhere else unimaginably far. And every one of those photons, unless it happens to strike your retina or a detector you have built, will continue traveling in a straight line through that emptiness effectively forever, never illuminating anything, never warming anything, never being seen. This is what darkness in the galaxy actually is. It is not an absence of light sources. There are hundreds of billions of light sources. It is the consequence of those light sources being so far apart and so small relative to the space they inhabit that their light cannot fill the volume between them. You can stand inside the Milky Way, surrounded by hundreds of billions of stars, and see darkness in almost every direction, because the stars are points and the darkness is everything else. Now, hold that realization and extend it one step further. The night sky misleads you in another way. When you look up and see stars, your brain registers them as a flat field, a dome of points at roughly the same visual distance. This is the same perceptual flattening that makes the moon look the same size, whether it is near the horizon or directly overhead. Your brain has no depth perception at astronomical distances. Every star, whether it is 4 light years away or 4,000 light years away, registers as a point of light on what feels like a curved ceiling. This flattening hides the true three-dimensional structure of the darkness. The gaps between stars are not two-dimensional patches of black on a flat surface. They are three-dimensional corridors extending outward in every direction. When you look at a dark patch between two bright stars, you're looking down a tunnel of vacuum that may be thousands of light years long, passing between stars that are nowhere near each other, missing every object in its path, and terminating either at the edge of the galaxy or at the edge of the observable universe. Every dark spot in the sky is a direction in which you are looking through the galaxy and seeing almost nothing. Not because nothing is there in an absolute sense, but because the probability of your line of sight intersecting a star at any given angle is extraordinarily low. Stars are too small and too far apart. If you were to draw a random line from your position outward through the Milky Way, the probability of that line intersecting a star before leaving the galaxy is extremely low. Most lines of sight pass through the entire galactic disk without touching a single stellar surface. The covering fraction of stars, the percentage of the sky that is physically blocked by stellar surfaces, is tiny. The rest is dark. This is why Olbers's paradox matters so much. The paradox asks why the sky is dark, and the answer reveals the architecture of everything. The sky is dark because the universe had a beginning, because light has a speed limit, because space is expanding and stretching ancient light into invisibility, and because stars, despite their numbers, are separated by distances so extreme that their light cannot fill the gaps between them. Every one of those reasons points to the same underlying truth. The universe is not full. It is mostly empty, and the darkness you see at night is the visible evidence of that emptiness. But here is what people miss when they stop at that explanation. Olbers's paradox explains why the sky is dark in a technical, optical sense. It tells you why photons do not fill every line of sight. What it does not tell you is what that darkness means when you scale it up. When you stop looking at the sky from the ground and start traveling outward, away from the Earth, away from the comforting glow of a nearby star, the darkness does not just continue, it intensifies, it deepens, it reveals layers of emptiness that the night sky, even on the clearest night, never hints at. Because the darkness you see from Earth is the most gentle version of cosmic darkness. It's darkness softened by proximity to a star. Darkness cushioned by the fact that you are sitting inside a solar system, within a galaxy, in a region of space that is, by cosmic standards, relatively crowded. Step outside that neighborhood and the darkness becomes something else entirely. Not just an absence of light, an absence of everything. And the distances involved are so large that the word dark stops meaning what you think it means. The nearest star to the solar system is Proxima Centauri, a dim red dwarf sitting approximately 4¼ light years away. Between our solar system and that star, there is effectively nothing. A vacuum so thorough it defies imagination. A gap so wide that the fastest spacecraft ever launched by human hands, traveling at its peak velocity, would take tens of thousands of years to cross it. And that is the shortest stellar gap in our entire neighborhood. Most gaps between stars are larger. That is the darkness between neighbors, between stars that, by galactic standards, are practically touching. The next scale outward, the scale between galaxies, between clusters, between the great structures of the cosmic web, makes the interstellar void look cozy by comparison. And that is where this story goes next. Because the gap between our star and the nearest other star is a puddle. The true depth of darkness lies beyond the edges of the Milky Way itself, in the intergalactic medium, where the density of matter drops so far below anything found inside a galaxy that the interstellar void, for all its emptiness, begins to feel almost crowded by comparison. That medium and the structures it separates and the scale of the emptiness it represents is what comes next. Start at the center of the solar system. Stand on Earth at noon under a clear sky and feel the light on your skin. The sun is 93 million miles away, roughly 1 astronomical unit, and from here it dominates everything. It fills the sky with blue through atmospheric scattering. It heats the ground beneath you. It drives the weather, the water cycle, the photosynthesis that built every calorie you have ever consumed. At 1 astronomical unit, the sun is not just a light source, it is the entire environment. Life on Earth exists because a star happens to be close enough that its radiation saturates the space around this planet, turning a cold rock into a world. Now, start moving outward, not fast, just steadily, away from the sun, toward the outer planets, into the regions of the solar system that most people never think about because no human being has ever been there. And in all probability, no human being alive today ever will. At the orbit of Mars, roughly 1.5 astronomical units from the sun, sunlight is already noticeably weaker. The sun still looks like a brilliant disk, but the light intensity at the Martian surface is only about 43% of what it is on Earth. Shadows on Mars are deeper. The sky is not blue but a thin, dusty butterscotch. The warmth that defines Earth's surface is already fading. Move further. At the orbit of Jupiter, roughly 5 astronomical units out, the sun delivers only about 4% of the light it delivers to Earth. You can still see it clearly. It is still the brightest object in the sky by an enormous margin. But the warmth is gone. The environment around Jupiter is cold, roughly minus 145 degrees Celsius on average. The sun at this distance looks smaller, not dramatically, not alarmingly, but enough that if you could stand on one of Jupiter's moons and look up, you would notice. The sun is receding. The darkness is growing. At the orbit of Saturn, roughly 9.5 astronomical units, sunlight drops to about 1% of its Earth intensity. At Uranus, roughly 19 astronomical units, it is 1/4%. And at Neptune, roughly 30 astronomical units from the sun, sunlight is approximately 900 times weaker than it is on Earth. 900 times weaker. That means standing on the surface of Neptune's moon Triton at local noon, you would experience a level of illumination roughly comparable to a dimly lit room on Earth. Not darkness, not yet, but a dimness that would strip the landscape of sharp detail and saturate color. A world where the sun has been reduced from a blazing furnace to a very bright star that still commands attention, but no longer dominates. Neptune is still inside the solar system. It is still gravitationally bound to the sun. It is still, by cosmic standards, absurdly close to home. The outer boundary of the solar system extends vastly further. The Oort cloud, the hypothesized shell of icy bodies that marks the sun's gravitational edge, is estimated to extend outward to roughly 1 light year from the sun, possibly further. At that distance, the sun is no longer recognizable as a special object. It is a star among stars. Bright? Yes. Brighter than most of what you see in the sky? Yes. But no longer dominant. No longer the center of everything. From the outer Oort cloud, you would look back toward the inner solar system and see nothing. Earth would be invisible. Mars, Jupiter, Saturn, all invisible. The sun itself would be a point of light, no disk visible to the naked eye. indistinguishable in kind from the thousands of other points of light scattered across the sky. That transition from a sky ruled by a single overwhelming star to a sky in which that star is just another dot happens within our own solar system. You do not have to cross interstellar space to lose the sun. You just have to back away far enough. And the thing that defines every moment of a life on Earth becomes one anonymous pinpoint among thousands. This is what most people never absorb about darkness in space. The comforting glow of a star is not a property of space. It is a property of proximity. Stand close enough and a star fills your world with light and warmth and meaning. Step back far enough and it vanishes into the field. The darkness was always there. You were just too close to the nearest lantern to see it. In 1990, the Voyager 1 spacecraft, then approximately 6 billion kilometers from Earth and on its way out of the solar system, turned its camera backward one last time. The image it captured became one of the most important photographs in human history. Earth appeared as a pale blue dot, less than a single pixel wide, suspended in a scattered beam of sunlight against a field of black. Carl Sagan, the astronomer who had lobbied for that photograph to be taken, described it in words that have been repeated millions of times since. That dot, he said, is everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, living out their lives on a mote of dust suspended in a sunbeam. What Sagan did not emphasize, but what the photograph shows with absolute clarity, is the darkness surrounding that dot. The black of the image is not artistic. It is literal. At 6 billion kilometers from the sun, the surrounding space is dominated by nothing. The pale blue dot is a speck of reflected sunlight floating in a void. Voyager 1 was still inside the solar system when it took that image. It had not even reached the heliopause, the boundary where the solar wind gives way to the interstellar medium. And already, home was nearly invisible. Already, the darkness has swallowed almost everything. Voyager 1 is now the most distant human-made object in existence. As of the current year, it is more than 24 billion kilometers from Earth, roughly 163 astronomical units from the Sun, traveling outward at approximately 17 kilometers per second. It has been flying for nearly 50 years, and it has not yet reached the nearest star. It has not reached anything. It is crossing a gap so vast that its half-century of continuous travel has covered only a fraction of 1% of the distance to Proxima Centauri. If Voyager 1 were aimed directly at Proxima Centauri, which it is not, it would arrive in approximately 73,000 years. 73,000 years of continuous travel through a darkness that contains functionally nothing. No rest stops, no landmarks, no surfaces, no matter worth measuring. Just a spacecraft the size of a small car drifting through a vacuum so complete that its instruments can barely distinguish the medium around it from pure nothingness, carrying a golden record that no one will ever play, heading toward a destination it will never reach in the lifespan of the civilization that launched it. And even that description overstates Voyager 1's presence in the void. The spacecraft is powered by the slow radioactive decay of plutonium-238, a process that generates less energy with each passing year. By roughly 2035, the decay will no longer produce enough electricity to run a single instrument. The transmitter will go silent. The heaters that keep the electronics from freezing will shut down. The last faint signal Voyager sends back to Earth will cross the void and arrive, and then there will be no more. After that, Voyager 1 will still exist. It will still be out there, drifting silently through the interstellar medium at the same velocity it held when it went quiet, carrying its golden record, its cameras, its magnetometer, but it will be inert, dark, cold, a small piece of metal and silicon cooling toward the temperature of the surrounding vacuum, just a few degrees above absolute zero. It will not announce itself. It will not reflect enough light for anyone to see it. It will be, for all practical purposes, a piece of the darkness, indistinguishable from the void it travels through. The one object humanity sent into the stars will become part of the dark long before it reaches anything in the light. That is the space between neighbors. Now picture the full scale. If you shrank the sun down to the size of a grapefruit and set it on a sidewalk in New York City, how far away would the nearest star be? Not across the street, not across the city. Proxima Centauri, at that scale, would be another grapefruit sitting on a sidewalk in Los Angeles, California. Two grapefruits separated by roughly 2,500 miles of empty space, and between them, at this scale, there would be nothing. No other grapefruits, no marbles, no grains of sand, just 2,500 miles of bare ground, open air, and silence. That is what the interstellar neighborhood looks like. Two tiny spheres separated by a distance so vast that the spheres themselves are meaningless specks relative to the gap. And here is what makes that picture worse. The Sun and Proxima Centauri are close neighbors. By galactic standards, they are practically touching. The average separation between stars in the Milky Way disk is roughly 5 light years, but that average hides enormous variation. In the spiral arms, where star formation is active and stellar densities are relatively high, neighbors can be as close as a light year or two. In the spaces between the spiral arms, the gaps stretch wider. In the halo of the galaxy, the diffuse shell of old stars surrounding the disk, separations can be tens or even hundreds of light years. Every one of those gaps is dark, not the comforting dark of a dimly lit room. The absolute dark of a vacuum with no source of illumination within trillions of kilometers. A human being placed in the middle of one of these gaps between two stars that are 5 light years apart would see stars in every direction. The sky would be full of points of light, more than you see from Earth, because there would be no atmosphere to scatter light and obscure faint objects. The sky would look astonishingly rich, and every point of light in that sky would be completely unreachable. This is the cruelty at the heart of interstellar darkness. It does not hide the light from you. It does not prevent you from seeing the stars. It lets you see them perfectly. It presents them clearly, sharply, beautifully. Each one a sun, many of them orbited by planets, some of those planets possibly harboring conditions compatible with life. The sky would be a catalogue of suns, displayed with the precision of a jeweler's case, each one labelled by its brightness and colour, each one a potential destination. And none of them would be reachable in a human lifetime. Not at any speed humanity has ever achieved. Not at any speed humanity is currently capable of theorizing how to achieve. The fastest spacecraft humans have ever built would take tens of thousands of years to reach the nearest one. And during those tens of thousands of years, the traveler would see nothing. No change in the star field. No approaching sun growing brighter. No sign of progress whatsoever. The stars would look exactly the same after 1,000 years of travel as they did on the day of departure. Because the distances are so grotesquely large that even thousands of years of movement covers a negligible fraction of the total. Interstellar space is not just dark, it is still. It is the most featureless environment that exists anywhere in nature. There is no wind, there is no sound, there is no surface, there is no up and no down. There is no weather, no temperature variation that a human body could detect. No particles dense enough to feel against your skin. The interstellar medium has a temperature of several thousand degrees, but because the particle density is so low, that temperature is meaningless in human terms. You could be surrounded by gas at 8,000 degrees and feel nothing, because the particles are so sparse that they would almost never touch you. The heat exists, but has no medium through which to transfer. A human drifting in interstellar space would not freeze to death because of the cold medium around them. They would radiate their own body heat into the vacuum and cool slowly, losing thermal energy to infrared radiation, beaming outward into a darkness that would absorb it without response. They would cool, and nothing around them would warm. The darkness would take what they radiated and give nothing back. There is a dimension of interstellar darkness that has nothing to do with physics, and everything to do with the machinery of the human mind. And it may be the most disturbing aspect of all. Human spatial awareness depends on reference points. Your brain builds its model of where you are by processing surfaces, edges, gradients of light and shadow, the ground beneath you, the ceiling above you, the walls around you. Even in an open field at night, you have the ground. You have the horizon. You have the difference between the dark sky above and the dark earth below. Your vestibular system, the balance organs in your inner ear, tells you which way is down. Your eyes confirm it. Your brain constructs a coherent spatial model with you at the center, and that model tells you where you are, how you are oriented, and what is around you. In interstellar space, every one of those inputs vanishes. There is no ground. There is no horizon. There is no surface in any direction at any distance that your eyes can resolve. The stars around you are points of light, but they provide no depth information. A star that is 4 light years away and a star that is 400 light years away look identical to the naked eye, differing only in brightness, and brightness alone cannot tell you distance because you do not know how luminous the source is. Your brain has no parallax, no motion cues, no atmospheric perspective, no familiar objects to use as scale references. The 3-dimensional model it normally builds collapses into a flat dome of points with no depth, no distance, and no structure. This is not a minor discomfort. It is a fundamental breakdown of the perceptual system that humans use to orient themselves in the world. Astronauts in low Earth orbit experience mild versions of this disorientation, and they are surrounded by the visible bulk of a planet filling half their visual field. A spacecraft a few meters away, suited colleagues within arm's reach, and the constant radio presence of mission control. Remove all of that. Place a human in true interstellar space with no spacecraft, no planet, no companion, nothing but points of light in every direction, and the brain has no model to build. There is no near and far. There is no here and there. There is no meaningful difference between looking left and looking right. Every direction is identical. Every direction is a void containing points of light at unknowable distances. The psychological term for this is spatial disorientation, but that term was developed for pilots who lose track of up and down inside a cloud. What interstellar space would produce is something more total. It is not disorientation within a space, it is the absence of space as a perceptual category. The brain would have nowhere to place itself because there would be no structure to place itself within. Darkness on Earth is always bounded. Even the darkest cave has walls. Even the open ocean at midnight has a horizon line and the pull of gravity pointing down. Interstellar darkness has no boundaries. It extends uniformly in every direction for distances that exceed the entire diameter of the solar system by factors of tens of thousands. There is no edge to find, no wall to touch, no floor to stand on. The darkness is not a container. It is an unbounded medium that the human perceptual system has no category for, no reference point within, and no ability to navigate. This is the kind of darkness that reveals something about human beings. We are not creatures built for emptiness. We are creatures built for surfaces, for boundaries, for the textured, layered, structured environments of a rocky planet illuminated by a nearby star. Take away the structure and the illumination, and we do not simply feel uncomfortable. We lose the basic framework through which we understand where we are. This is the physical character of the space between stars. It is not merely unlit. It is non-participatory. It does not interact with you. It does not reflect, absorb, scatter, or return anything. It is the closest thing in nature to a true nothing. A space that exists in the physical sense but contains so little that it behaves, for all human purposes, as if it is empty. And the Milky Way has hundreds of billions of these gaps. Try to hold the full picture. Hundreds of billions of stars, each one a nuclear furnace burning at thousands or millions of degrees, pouring light outward in every direction, and between them, gaps so vast and so vacant that the combined light of all those furnaces cannot fill the space they inhabit. Each star illuminates a tiny sphere around itself, a bubble of light that extends outward and weakens with the square of the distance until it becomes indistinguishable from the cosmic background. Beyond that bubble, darkness. Between every pair of neighboring stars, a chasm of darkness. Between every cluster and every arm and every region, more darkness. The Milky Way is a structure made of light, held together by gravity, and it is almost entirely dark. This is not a poetic restatement, it is a physical description. If you could somehow compress the Milky Way and see its volume as a transparent block, the stars would be scattered through it like dust motes in a cathedral. Visible, yes. Present, yes. But nowhere close to filling the space they occupy. The block itself would be, to any reasonable measurement, empty. Now consider what this means for anything living inside it. Every civilization that has ever arisen, if any have besides ours, did so on a planet orbiting one of those dust motes. It built its understanding of the universe by looking outward from its tiny sphere of warmth and seeing the same thing we see. Points of light in a dark sky. And it faced the same problem we face. The points of light are real, the distances between them are real, and the distances win. The darkness between stars is not a problem to be solved by faster engines or better technology, at least not within any physics we currently understand. Even at the speed of light, crossing the gap to the nearest star would take over 4 years. Crossing the galaxy would take 100,000 years. And nothing with mass can reach the speed of light. The energy required approaches infinity as you approach that limit. Practical interstellar travel will likely involve speeds far below that ceiling, meaning transit times measured in decades at best, millennia at worst. The darkness is a barrier. It is not a passive backdrop. It is an active separator, a physical medium of near nothingness that isolates every star from every other star by distances that overwhelm any technology ever built or currently imagined. And every year, new measurements confirm that the average density of the interstellar medium is even lower than previous estimates suggested. The space between stars is becoming better understood, and the better we understand it, the emptier it turns out to be. There is one more detail about interstellar darkness that rarely gets discussed, but that changes the way you should think about the night sky forever. When you look up at the stars from Earth, you are seeing light that left those stars years, decades, centuries, or millennia ago. The star you're looking at may not even exist anymore. It may have exploded, collapsed, or cooled below visibility during the time its light was traveling toward you. The night sky is not a live image. It is a composite of outdated signals, each one showing you where a star was and how bright it was at the time the light departed, not where it is now. This means the darkness between stars is not just spatial, it is temporal. The gaps between stars are gaps in time as well as space. When you look at a star 400 light years away, you are seeing it as it was 400 years ago. The space between you and that star is not just empty, it is old. Light has been crossing it for 4 centuries, and during that crossing, it interacted with almost nothing. It traveled through a void so thorough that 400 years of travel at the fastest speed in the universe produced no events, no collisions, no interactions worth recording. That is what 400 light years of interstellar space contains. 400 years of nothing happening to a photon. Now multiply that by the full scale of the galaxy. Light from the far side of the Milky Way has been traveling for 100,000 years. It departed from a star when anatomically modern humans were in the early stages of migrating out of Africa. Every photon that reaches your eye from those distant stars has spent longer in interstellar darkness than human civilization has existed. It crossed the galaxy in silence, touching nothing, illuminating nothing, carrying a message from a source so far away that the photon's entire journey is longer than the history of every city, every language, and every recorded thought. And the overwhelming majority of photons emitted by every star in the galaxy will never reach any eye at all. They will travel outward into the interstellar medium and continue traveling, past the edge of the galaxy, into intergalactic space, into the voids between galaxy clusters, into regions so empty that the word interstellar sounds crowded by comparison. Most of the light produced by most of the stars in the Milky Way will never illuminate anything. It will travel through darkness forever, unobserved, unrecorded, carrying energy that will never be absorbed by anything. The galaxy is a machine that produces enormous amounts of light, and the darkness swallows almost all of it. That is the second layer of the darkness of space. The first layer is that the sky looks deceptively full when viewed from Earth. The second layer is that even within a galaxy containing hundreds of billions of stars, the distances between those stars are so extreme and the space between them so empty that the galaxy itself is overwhelmingly dark. The stars are exceptions. The darkness is the norm. And the norm is so dominant that standing beside one exception, you can see the glow of others scattered across the sky, each one real, each one a fire burning in the void, and every photon they send toward you crossing that void without touching a single thing on its way. That picture, stars as rare exceptions in an overwhelming dark, is comforting in one sense. It implies that at least the exceptions exist. At least they are there. At least if you could somehow cross the gap, there would be something on the other side. But here is where the story takes its most unsettling turn. The Milky Way is itself an island. The entire galaxy, all 100,000 light years of it, all 200 to 400 billion stars, is a single structure floating in a darkness that dwarfs everything described so far. The space between galaxies makes the space between stars look intimate, and the structures that galaxies form, the clusters and superclusters and filaments of the cosmic web, are separated by voids so enormous and so empty that they fundamentally change what the word darkness means. Because at the galactic scale, the darkness between stars is at least populated with a thin fog of atoms, 1 per cubic centimeter. Not much, but something. A measurable trace of matter that tells you the galaxy has substance, that it is a physical structure with an interior. The space between galaxies has roughly 1 atom per cubic meter, 1,000,000 times emptier than the space between stars. A vacuum so extreme that it makes the interstellar medium look like a thick atmosphere. And the gaps between galaxies are not measured in light years. They are measured in millions of light years. The nearest large galaxy to the Milky Way is Andromeda. The distance between here and there makes the interstellar gaps described look vanishingly small. And what fills that distance will fundamentally change what the word darkness means. That is the scale of what comes next. And at that scale, the darkness stops being merely an absence of light. It becomes the primary structural feature of the universe itself. The thing that everything else is embedded in. The thing that defines where everything is by defining how far apart everything sits. The islands of light are real, but the dark between them is bigger than all of them combined. And it is growing. Until now, this story has moved through darkness at scales that are at least imaginable. The shadow behind the moon, the dimming of sunlight past the outer planets, the vacuum between neighboring stars. Those are enormous distances, yes, but they are distances within a single structure. The Milky Way galaxy, for all its emptiness, is a coherent object. Its stars orbit a common center. Its gas and dust circulate through spiral arms. Its gravity holds it together. You can think of it as a place, an island, a home territory, however vast and mostly dark it may be. What comes next is different, because the darkness between galaxies is not just a larger version of the darkness between stars. It is a different category of emptiness entirely. And the structures it separates are so far apart, and the voids between them so enormous, that the word darkness begins to mean something the human mind was never designed to process. Start with the local picture. The Milky Way is not alone. It belongs to a small collection of galaxies called the local group, a gravitationally bound cluster of more than 50 galaxies spread across roughly 10 million light years. The local group includes the Milky Way, the Andromeda Galaxy, the Triangulum Galaxy, and dozens of smaller dwarf galaxies orbiting around the larger ones like satellites. 10 million light years sounds unimaginably vast, and it is. But in the context of the observable universe, the local group is a tiny neighborhood. It is a small clump of matter in a cosmic structure that extends for billions of light years in every direction. And even within this small neighborhood, the dominant feature is not the galaxies. It is the space between them. The Milky Way and Andromeda are separated by approximately 2.5 million light years. Between them sits a region of intergalactic space so empty that it redefines what the word vacuum means. The interstellar medium inside the Milky Way, thin as it is, has a density of roughly 1 atom per cubic centimeter. The intergalactic medium between the Milky Way and Andromeda has a density roughly 1,000,000 times lower, approximately 1 atom per cubic meter. One single atom floating alone in a volume of space the size of a large closet. To understand how empty that is, consider that the best laboratory vacuums on Earth, the most thoroughly evacuated chambers human technology has ever produced, still contain on the order of 10,000 atoms per cubic centimeter. The intergalactic medium is emptier than any vacuum we have ever built by a factor of tens of billions. It is emptier than the space between stars by a factor of roughly 1,000,000. It is a void so thorough that if you could somehow place yourself in the middle of it, there would be functionally nothing within millions of kilometers of you in any direction. No atom close enough to interact with. No photon dense enough to register as illumination. No particle of any kind passing close enough to your body to detect. This is the medium that fills the space between galaxies. And it fills a lot of space because galaxies, like stars within them, are separated by distances that overwhelm their own sizes. The Milky Way disk is roughly 100,000 light-years across. The gap to Andromeda is 2.5 million light-years. That means the gap between our galaxy and its nearest large neighbor is approximately 25 times the diameter of the galaxy itself. If the Milky Way were the size of a dinner plate, Andromeda would be another dinner plate sitting 25 plate widths away across an empty table. And that is the nearest large galaxy. The next significant cluster of galaxies, the Virgo cluster, is roughly 54 million light-years away. The distance to the nearest large supercluster of galaxies, beyond our own, is hundreds of millions of light-years. The spaces between these structures are not just big, they are the dominant feature of the universe. They are what the universe mostly is. This is where the framing has to shift. Earlier, darkness was an illusion the sky hides from you. Then it was the gap between neighboring stars. Here, darkness becomes the organizing principle of reality itself. Because when you zoom out far enough to see the universe's large-scale structure, what you find is not a space filled with galaxies. It is a space filled with nothing, threaded by impossibly thin filaments of matter that galaxies cling to like dew on a spider's web. This structure has a name. It is called the cosmic web, and it is one of the most important discoveries in the history of cosmology. The cosmic web is the large-scale arrangement of matter in the observable universe, predicted by computer simulations in the 1980s and confirmed by galaxy surveys in the decades that followed. The structure looks like a vast sponge. Matter is concentrated in thin filaments and sheets that surround enormous empty regions. The filaments are where the galaxies live. The empty regions between them are called cosmic voids. The voids are the dominant feature. They are not the background. They are not the spaces left over after the galaxies formed. They are the primary component of the universe's volume. Current estimates suggest that cosmic voids account for approximately 80% of the observable universe's volume. 80%. The galaxies, the clusters, the superclusters, the filaments, the walls, all the luminous matter, all the structure, all the light, all the warmth, everything you have ever seen in a telescope or a photograph of the cosmos fits within the remaining 20%. The universe is 80% void, 80% darkness, 80% emptiness so extreme that the voids contain, on average, less than 1/10 the density of matter found in the cosmic average. Some voids are even emptier than that, approaching densities so low that they begin to look like true nothingness. And here is a detail that pushes the story further in a direction most people are not prepared for. The Milky Way itself may be sitting inside a void. In 2013, astronomers identified a large underdense region surrounding our galaxy and its neighbors. They called it the KBC Void, after the researchers Keenan, Barger, and Cowie who characterized it. The KBC Void, sometimes referred to as the local hole, is estimated to be roughly 2 billion light-years in diameter, making it significantly larger than the BO-OHT's void. Its interior density appears to be roughly 20 to 40% below the cosmic average. The implications took years to fully register. If the Milky Way sits inside a region that is meaningfully emptier than the universe's average, then the local expansion rate of space around us could differ from the global rate. This is because the outward push of dark energy inside a void is less opposed by gravity than it would be in a denser region. Some researchers have proposed that the KBC void could be part of the explanation for the Hubble tension, the persistent disagreement between different methods of measuring how fast the universe is expanding. The expansion we measure locally may be slightly faster than the cosmic average, precisely because we are inside a hole. The scientific community has not reached full consensus on the KBC void's size or significance. Some studies support the measurements. Others argue that the underdensity is less extreme than initial estimates suggested. But the basic observation that the region of the cosmos surrounding the Milky Way is less dense than average is supported by multiple independent datasets. Think about what that means for the argument this story is building. The universe is 80% void. Galaxies are thin concentrations of matter on the walls between those voids. And our galaxy, specifically, appears to sit in a region that is itself emptier than the walls are supposed to be. We are not on a well-populated wall of the cosmic web surrounded by typical densities. We may be in one of the thinner parts, a region where the darkness around us is more pronounced than it is around many other galaxies. The darkness of space is not just worse than most people think. It may be worse for us specifically, because of where we happen to be. The most famous of these voids has a name that astronomers sometimes deliver with a slight pause, as if the scale of the thing demands a moment of silence before describing it. It is called the BO-OHT's void. Sometimes it is called the Great Nothing. Located roughly 700 million light-years from Earth in the direction of the constellation BO-OHT's, it is one of the largest known voids in the observable universe. It stretches approximately 330 million light-years across. To place that in context, the Milky Way is 100,000 light-years wide. The BO-OHT's void is roughly 3,300 times the diameter of our entire galaxy. You could line up thousands of Milky Ways across it and still have room left over. And inside this colossal volume, there is almost nothing. Astronomers have found roughly 60 galaxies within the BO-OHT's void. 60. In a region where, based on the average density of the surrounding universe, you would expect to find approximately 2,000. The void is not just empty relative to a laboratory or a human room, it is empty relative to the rest of the cosmos. It is a hole in the universe's structure, a region where the processes that built galaxies and clusters and superclusters simply did not operate with the same intensity as everywhere else. Astronomer Greg Aldering captured the implications of this emptiness in a sentence that has been quoted in every serious discussion of cosmic voids since he said it. If the Milky Way had been located in the center of the BO-OHT's void, he said, we would not have known there were other galaxies in the universe until the 1960s. Let that settle. A civilization in the center of that void, looking outward with the same telescopes available to humanity in the 1950s, would have seen nothing beyond its own galaxy. No Andromeda, no Virgo cluster, no visible evidence that the universe contained anything beyond a single island of stars, surrounded by an infinite, featureless darkness. They would have spent their entire scientific history believing they were alone, not because other galaxies did not exist, but because the nearest ones were too far away and too faint to detect with any technology available at the time. That is what a void does. It does not just create darkness, it creates isolation. It removes the evidence that anything else exists. A civilization trapped in a void would not merely be far from its neighbors, it would not even know it had neighbors. The darkness would not just surround it, it would define the boundaries of its knowable reality. And the BO-OHT's void, enormous as it is, may not even be the largest void in the observable universe. In 2015, researchers found evidence of a void approximately 1.8 billion light-years across, located in the direction of a cold spot in the cosmic microwave background. If confirmed at that scale, it would be a region so empty that light crossing it would take almost as long as the current age of the Earth. Nearly 2 billion years of travel through a darkness containing almost nothing at all. These voids are not anomalies. They are the standard structure. The cosmic web is defined by its voids, the way a sponge is defined by its holes. The holes are the main feature. The thin walls of material between them are the exceptions, the compressed remnants of a universe that began as a nearly uniform fog of matter and, over billions of years, sorted itself into dense filaments and empty voids through the slow pull of gravity. The process worked like this. In the first moments after the beginning of the universe, matter was distributed almost uniformly. Almost. There were tiny variations, quantum fluctuations, regions where the density was fractionally higher or lower than the average. Over hundreds of millions of years, gravity amplified those tiny differences. Regions that were slightly denser pulled in more matter from their surroundings, growing denser still. Regions that were slightly less dense lost matter to the denser regions and became emptier. The rich got richer, the poor got poorer. And the result, after billions of years of this gravitational sorting, is the universe you see today. Thin walls of concentrated matter surrounding enormous bubbles of nearly nothing. The voids grew as matter drained out of them. And as they grew, they became environments unlike anything else in the cosmos. Inside a void, the rules change. The density of matter is so low that gravity's influence is negligible. Dark energy, the mysterious force driving the accelerating expansion of the universe, becomes the dominant player. Inside a void, dark energy is not competing with gravity. It is essentially unopposed. It pushes the walls of the void outward, stretching the space between the few scattered galaxies that remain, accelerating the emptiness. Recent research published in 2025 and 26 has confirmed what theoretical models predicted. Cosmic voids are the places where dark energy does its work most visibly. The expansion of the universe is not happening uniformly. It is concentrated in the voids, where matter's gravitational resistance is weakest. The voids are growing. They are stretching. And as they expand, they slowly push the filaments of the cosmic web further apart, thinning the connections between galaxy clusters, weakening the bridges of matter that link the luminous structures of the universe. The long-term implication is staggering. Over billions of years, the voids will win. The cosmic web will thin and fragment. The filaments will stretch beyond the point where galaxies can form new connections. The clusters will drift apart, and the universe will trend toward a state where each gravitationally bound group of galaxies sits alone, surrounded by a void so large that no light from any other structure will ever reach it. That future is not speculative. It is the prediction of every major cosmological model that includes dark energy. The observable universe in the deep future will consist of isolated islands of matter, separated by darkness so total and so permanent that it will be indistinguishable from infinity. Now, bring the focus back to the present and consider what the current architecture of the universe tells you about the nature of light and darkness. There are somewhere between 200 billion and 2 trillion galaxies in the observable universe, depending on which survey and which definition you use. Each of those galaxies contains billions or hundreds of billions of stars. The total number of stars in the observable universe is estimated at roughly 200 billion trillion. That is a 2 followed by 23 zeros. It is a number so large that no human being can hold it in their mind as a quantity. It is pure abstraction, and yet all those stars, every one of them, every galaxy that contains them, every cluster and filament and wall of the cosmic web, fits within 20% of the observable universe's volume. The other 80% is void. And even within the 20% that contains structure, the matter itself is overwhelmingly diffuse. Ordinary matter, the kind made of atoms, the kind that forms stars and planets and people, constitutes roughly 5% of the total mass energy content of the observable universe. The rest is dark matter, roughly 27%, and dark energy, roughly 68%. Neither of those produces light. Neither of them is visible. So even if you could see all the ordinary matter in the universe, you would be seeing 5% of what exists, concentrated in 20% of the available volume. The remaining 95% of the universe's mass energy content is invisible by nature, and 80% of its volume is void. The universe is a structure in which almost everything is dark, almost everything is empty, and the things that produce light are so rare and so thinly distributed that they occupy a fraction of the total so small it borders on the absurd. Stars contain only about half of 1% of all matter in the universe. Half of 1%. The luminous objects, the things that generate the light that makes the universe visible, account for 1 part in 200 of the total material. The other 99.5% of matter is non-luminous. It floats in intergalactic space, hides in dark matter halos, drifts as cold gas in galactic outskirts, or exists in forms that produce no detectable light at all. The universe is not a lit room with dark corners. It is a dark room with a handful of lit matches scattered across a space the size of a continent, and the matches are burning out. Here is where the emotional weight of these numbers begins to press, because the darkness of space, at this scale, stops being a measurement and becomes a statement about the character of reality. The human relationship with darkness has always been one of proportion. Darkness was the smaller portion of waking experience. Humans are diurnal, active during the lit hours, and asleep through most of the dark. Lit spaces outnumbered dark ones. The balance always favored the light, and every human culture built its sense of normality around that balance. The assumption is so deep, it feels biological, not cultural. Light is the usual state of things. Darkness is the exception, the interruption, the temporary condition that passes. The numbers described invert the assumption completely. None of those associations apply to the cosmos. Cosmic darkness does not end. It does not yield to morning. It is not a temporary condition waiting for a light source to resolve it. It is the permanent, structural, default state of almost everything that exists. The light is the interruption. The light is the anomaly. The light is the brief, local, temporary exception to a rule that governs 95% of the universe's content and 80% of its volume. When you look at a photograph of a galaxy cluster taken by the Hubble or James Webb Space Telescopes, you see a field of glowing objects against a black background. Your brain processes that image the way it processes any photograph. It focuses on the objects. It treats the black background as empty space, as negative space, as the canvas on which the interesting things are displayed. But the canvas is not the background. The canvas is the subject. The glowing objects are the decoration. The darkness between those galaxies is the universe's primary material, and the galaxies are scattered through it like grains of salt thrown across a dark floor. There is one more structural feature that makes the dominance of darkness explicit. It is the scale of the largest structures galaxies actually belong to, measured against the voids those structures border. In 2014, a team of astronomers mapped the gravitational watershed to which the Milky Way belongs. They called it La Ni Akai A, a Hawaiian term meaning immense heaven. La Ni Akai A is a supercluster, a vast basin of gravitational attraction that contains roughly 100,000 galaxies, spread across approximately 500 million light years. 100,000 galaxies sounds like a crowded neighborhood. It is not. 500 million light years is an almost incomprehensible volume of space, and 100,000 galaxies scattered across it means that the average distance between those galaxies is enormous. The galaxies within Laniakea are not packed tightly. They are strung along filaments and walls like beads on widely separated threads, with voids between the threads that are tens of millions of light years across. And Laniakea itself, this structure containing 100,000 galaxies and spanning 500 million light years, is bordered by voids of comparable size. The Milky Way sits near one edge of the supercluster, close to the boundary with adjacent voids. The gravitational pull of Laniakea is drawing our galaxy and its neighbors slowly inward, toward the center of the basin. But the voids on the other side of the boundary are doing the opposite, stretching space outward, thinning the connections, widening the dark. This is the pattern at every scale. Stars are points in a dark galaxy. Galaxies are points in a dark cluster. Clusters are points in a dark supercluster. And superclusters are thin smears of matter on the surfaces of bubbles, whose interiors are void. At every level of magnification, the same truth reappears. The luminous structures are the minority feature. The darkness between them is the majority. And the ratio does not improve as you zoom out. It gets worse. The larger the scale, the more the void dominates, the thinner the structures become, and the more clearly the universe reveals itself as a place defined not by what it contains, but by the overwhelming emptiness between the things it contains. Laniakea is one of the largest structures ever identified in the observable universe, and it is a thin film of matter surrounding darkness, a membrane of galaxies stretched across voids that would take hundreds of millions of years to cross at the speed of light. The immense heaven is almost entirely empty. Consider one more number. A study published in 2025 used observations from fast radio bursts to trace where ordinary matter resides in the universe. The results confirmed what simulations had predicted. Roughly 76% of all normal matter in the universe lies in the intergalactic medium, the near vacuum between galaxies. Another 15% sits in galaxy halos, the diffuse outer regions surrounding the visible stars. Only 9% of all normal matter resides inside galaxies themselves, in stars and cold gas. 9%. The stuff that generates light, the stuff that forms planets, the stuff that builds everything you have ever known or touched or loved, accounts for 9% of the ordinary matter in the universe. And ordinary matter itself accounts for only 5% of the total mass energy. You are made of the rarest category of the rarest material in a universe that is almost entirely dark, almost entirely empty, and almost entirely indifferent to the existence of light. This is not a poetic exaggeration. It is a description of measured physical reality confirmed by multiple independent observational programs across the last decade. The universe is built around darkness. Light is an afterthought. Now add one more layer to this picture, one that makes the darkness not just dominant in the present, but victorious in the future. The universe is expanding. It has been expanding since its beginning, and for the last several billion years, that expansion has been accelerating. Every galaxy outside our local group is moving away from us, not because it is traveling through space, but because the space between us and that galaxy is stretching. The further away a galaxy is, the faster the space between us stretches, and the faster that galaxy appears to recede. At a certain distance, the expansion of space becomes so rapid that light from a receding galaxy can never reach us. The galaxy crosses what is called the cosmological horizon. It does not disappear in a flash. It does not wink out. Its light simply redshifts further and further toward longer wavelengths, grows fainter and fainter, and eventually fades below the detection threshold of any conceivable instrument. The galaxy is still there. It still produces light, but its light will never reach us again. It has been swallowed by the expansion. This is already happening. Many galaxies that were once visible in the observable universe have already crossed the horizon. Their light will never reach Earth again, regardless of how long we wait or how sensitive our telescopes become. The observable universe, the portion of reality that light can connect us to, is shrinking in terms of the number of objects it will eventually contain. In the very long term, trillions of years from now, the expansion will have carried every galaxy beyond the local group past the cosmological horizon. The night sky of that far future will contain only the stars of whatever merged remnant the Milky Way and Andromeda have become. Surrounded by a darkness that extends in every direction without limit. No other galaxies visible, no cosmic microwave background detectable, because it too will have been redshifted beyond the sensitivity of any instrument. No evidence that the universe ever contained anything else. A civilization arising in that era would look out at the cosmos and see a single galaxy surrounded by absolute, total, permanent blackness. They would have no way of knowing that the universe was ever any different. No way of knowing that billions of galaxies once filled the sky. No way of knowing that the darkness around them was not a natural boundary, but the result of an expansion that erased the evidence of everything else that ever existed. The darkness of the future universe will not just be the absence of light. It will be the absence of information, the absence of connection, the absence of any evidence that the cosmos was ever anything other than a single lonely island floating in an infinite void. That is the trajectory. That is the direction the universe is heading. Not toward more light, not toward greater connection, not toward a cosmos that fills itself with warmth and luminosity, but toward a darkness so complete that it will eventually erase the knowledge that light was ever abundant. The voids are growing. The filaments are thinning. The cosmic web is being pulled apart by a force that operates most powerfully in the emptiest places, the places where darkness already reigns. The darkness is not just winning, it has always been winning. The era of light, the era in which stars burn and galaxies cluster, and the cosmic web still holds together, is a phase. A temporary phase in the life of a universe whose equilibrium state is cold, dark, and empty. The light you see when you look at the night sky is not the universe's normal condition. It is a brief interruption in a darkness that preceded it, and will outlast it by a margin so vast that the entire age of stars will be a footnote. And within that footnote, within this brief era of luminosity, the darkness still dominates. 80% of the volume, 95% of the content, 91% of even the ordinary matter floating invisibly between galaxies. The era of light is not just temporary. Even at its peak, even now it is a minority condition. This is the deepest layer of the darkness of space yet. First came the illusion that the sky is full. Then the emptiness between stars within a galaxy. Now the realization that the large-scale structure of the universe is built around voids. That galaxies are thin decorations on the walls of enormous empty bubbles. And that the darkness between those structures is the defining feature of reality, not the exception to it. And there is one more thing to confront. One that takes everything described so far and asks what it means. Not what it measures, not what it predicts, what it means for anything that lives inside it. What it means for any island of warmth and light that looks outward and sees the true scale of the dark. That is what remains. Everything described so far has been measurement. Numbers, distances, densities, volumes, the fraction of the universe that is void, the fraction of matter that produces light, the fraction of light that reaches any given observer, all of it confirmable, all of it published, all of it consistent across independent observations spanning decades. None of it controversial in the scientific community, but measurement alone doesn't explain why the darkness of space is worse than you think. Numbers can tell you the universe is mostly empty. They cannot tell you what that emptiness means to anything living inside it. And the meaning is where the real weight of this story lands. So let us stop measuring and start asking what the darkness tells us about the kind of universe we actually live in. Begin with the simplest version of the question. When a person imagines the darkness of space, what do they usually picture? Most people picture a black sky with stars in it. They picture an astronaut floating against a dark backdrop, or a planet hanging in shadow, or the view from a spacecraft window showing a field of distant points of light. The darkness in these images is a background. It is the canvas. The interesting things, the astronaut, the planet, the stars, are in the foreground, and the darkness is just the empty space behind them. That framing is exactly backward, and correcting it is the entire point. The darkness is not the background. The darkness is the foreground. It is the main character. It is the thing the universe is primarily made of. The thing that occupies most of the space, contains most of the volume, and defines most of the structure. The stars and galaxies are not the substance of the cosmos, with darkness filling the gaps between them. The darkness is the substance of the cosmos, with stars and galaxies scattered through it so thinly that they barely register as a presence. That distinction sounds like wordplay, but it is not. It changes what the universe fundamentally is. A universe where stars are the main feature and darkness is the gap between them is a universe of connection. It is a place where the important things are the lit, warm, matter-rich structures, and the spaces between them are just distances to be crossed. In that universe, the darkness is a problem to be solved. Build faster ships, and the stars get closer. Build better telescopes, and the dark patches fill with light. The darkness is an inconvenience, a challenge, a temporary condition waiting for technology to overcome it. A universe where darkness is the main feature and stars are the rare interruptions is a different kind of place entirely. In that universe, connection is the anomaly. Warmth is the exception. Light is a temporary, local phenomenon that exists only because matter happened to collapse densely enough in scattered points to ignite nuclear fusion. The darkness is not waiting to be solved. It is the default state of existence, and the islands of light within it are not connected to each other by anything except the faintest threads of gravity and the thinnest traces of radiation. They are alone in the most physical sense of the word, surrounded by a medium that does not support life, does not carry sound, does not permit rescue, and does not end. This is what the darkness of space actually represents. Not a visual quality, not a color, not an aesthetic mood. The darkness is the visible evidence that the universe is built around separation. Every dark stretch between the farthest visible structures in the cosmos is a barrier so wide that even light, traveling since the very beginning, has not had time to cross it. And now, because of the accelerating expansion, it never will. The darkness does not hide the light. This is what makes it worse than people expect. The darkness shows you the light. It lets you see every star, every galaxy, every point source of warmth and illumination in the sky. It presents them to you with perfect clarity. And then, by the sheer scale of the space surrounding them, it tells you that you cannot reach them. Not in a human lifetime, not in 100 human lifetimes, not with any engine or fuel or trajectory that currently exists within the boundaries of known physics. The cruelty of cosmic darkness is not that it is black, it is that it is transparent. You can see through it. You can look across 4 light years of interstellar void and see Proxima Centauri shining clearly. A small red star, probably orbited by planets, one of them sitting in the habitable zone. You can see it. You know it is there, and you cannot get to it. The light from that star reaches your eye in just over 4 years, traveling effortlessly across a gap that no human technology can cross in less than tens of thousands of years. The darkness lets the message through and blocks the messenger. That is the nature of cosmic isolation. It is not like being lost in a dark forest where you cannot see the path. It is like being stranded on a small island in the middle of an ocean, so wide you can see the lights of other islands on every horizon, twinkling and clear And knowing that the water between you and them is deeper than any ship can survive, wider than any swimmer can cross, and colder than any body can endure. The lights are visible. The distances are lethal. Now extend that picture to the full scale of the universe. Not one island in one ocean, but billions of islands scattered across an ocean that takes up 80% of the surface. Each island is a galaxy, a collection of hundreds of billions of fires burning on a rock of matter surrounded by a void so enormous that the fires of the nearest other island are millions of light years away. The ocean between them contains almost nothing, 1 atom per cubic meter, a vacuum so absolute that nothing living, nothing mechanical, nothing physical in any form could cross it without carrying every resource it would ever need for a journey lasting millions of years. And the ocean is growing. The expansion of space is pushing the islands further apart. The voids are stretching. The filaments of the cosmic web are thinning. In the deep future, each island will drift beyond the horizon of every other island, and the ocean will be all that remains. An infinite, permanent, irreversible darkness surrounding each surviving cluster of matter, with no light from any external source ever reaching it again. And the losses are not abstract. They are specific. Every galaxy that crosses the cosmological horizon takes with it every star it contains, every planet orbiting those stars, every possible world, every possible civilization, every possible observer who might one day have looked toward us and wondered whether anyone was here. When a galaxy crosses the horizon, it does not simply become too faint to see. It becomes permanently, physically, irreversibly unreachable. No signal sent after that moment will ever arrive there. No signal sent from there will ever arrive here. The connection is not weakened, it is severed. The expansion of space has placed an absolute barrier between that galaxy and ours that no technology, no matter how advanced, can overcome, because the barrier is not a wall or a distance. It is the ongoing creation of new space between 2 points, faster than light can cross it. Each crossing is a small death of connection, a quiet, invisible amputation of the observable universe. And it is happening continuously. The darkness is not merely present, it is advancing. It is taking galaxies away from us one by one, folding them behind a horizon from which nothing returns. And unlike every other form of darkness in this story, this one cannot be reversed. No future technology, no future telescope, no future civilization, however advanced, will ever recover what the expansion takes. This is not a metaphor. This is the measured trajectory of the physical universe, and it means that the darkness of space is not a static condition. It is a process. It is an ongoing, accelerating erasure of connection between the structures that produce light. Every year, the observable universe loses access to more galaxies as they cross the cosmological horizon. Every year, the voids grow slightly larger, and the filaments grow slightly thinner. Every year, the universe becomes a little more dark, a little more separated, a little more isolated. The era in which we exist, the era in which stars burn and galaxies cluster and the cosmic web still holds together, is a window. It is not the permanent state of the cosmos. It is a phase, and it is a phase that is already past its peak. The rate of star formation in the universe peaked roughly 10 billion years ago, and has been declining ever since. The fuel is running out. The cold gas clouds that collapse under gravity to form new stellar nurseries are being consumed, heated, or dispersed by the very processes that created the current generation of stars. The total number of stars in the universe will continue to grow for some time as existing gas clouds continue to collapse, but the rate is slowing. Eventually, perhaps in a few trillion years, the last star will form. And when the last star dies, when the last nuclear furnace burns through its fuel and fades to a cooling ember, the universe will enter a state that it will occupy for the overwhelming majority of its existence. A state of total darkness. No stars, no light, no warmth. Just the cooling remnants of dead suns drifting through an expanding void, growing colder and dimmer across timescales so vast that the entire era of starlight will be a rounding error in the cosmic timeline. The darkness is not just the present condition of most of the universe, it is the future condition of all of it. Everything you have ever seen in a telescope, every galaxy, every nebula, every glowing cloud of gas, every star is temporary. The darkness that surrounds them is permanent. And the ratio between the temporary and the permanent is so lopsided that the era of light, viewed from the perspective of the full timeline of the universe, will be over almost before it begins. This is what makes the darkness of space worse than people think. It is not merely that space is dark right now. It is that darkness is the natural state of the universe, and light is the brief, rare, local departure from that state. The universe didn't start bright and become dark. It started as a hot, opaque fog, cooled into transparency, produced a few trillion stars across a few trillion galaxies during a window of activity that amounts to a tiny fraction of its total lifespan, and will spend the rest of eternity in a darkness that no future observer will ever be able to distinguish from infinity. And even during this window, even now, at the peak of the era of light, the darkness still dominates. It occupies more volume, contains more mass energy, and separates more structures than all the light in the cosmos combined. The stars are losing even during their only turn at bat. Now, consider what this means for anything alive. Life, as far as we know, requires warmth. It requires chemistry. It requires a stable energy source and a surface or medium where complex molecules can interact. Every one of those requirements is met only in the immediate vicinity of a star. Life zones, habitable zones, the narrow shells around stars where water can exist as liquid, are tiny compared to the space they sit in. The habitable zone of our own sun extends from roughly 0.95 to 1.4 astronomical units. Beyond that outer shell, the environment is too cold. Inside it, too hot. The zone itself, measured against the distance to the nearest star, is a sliver so thin it is almost imaginary. A warm strip, roughly 67 million kilometers wide in a gap of 40 trillion kilometers of nothing. That is the ratio. A few 100 million kilometers of habitability in a void of 47 trillion kilometers of nothing. And that ratio is one of the better ones in the galaxy. Many stars have habitable zones that are narrower. Many have no planets within them. Many have planets that are uninhabitable for other reasons. No atmosphere, no magnetic field, no stable climate, too much radiation. The number of places in the galaxy where life could plausibly exist is a vanishing fraction of the total volume. The darkness of space is the visible evidence that the universe does not produce habitable environments generously. It produces them rarely in tiny pockets around scattered sources of energy that are themselves temporary. And it separates those pockets by distances so enormous that no plausible exchange between them can occur within the lifetimes of any beings living in them. This is what isolation means at the cosmic scale. Not the feeling of being alone, the physical reality of being alone. Every potentially habitable world is an oasis separated from every other oasis by a desert so vast, so empty, and so impassable that the oases might as well exist in different universes. The darkness between them is not a gap to be crossed. It is a wall that cannot be breached. Not in principle. In principle, you could cross it given enough time and energy. But the time required exceeds the lifespan of any biological organism. And the energy required exceeds the output of civilizations. The darkness enforces separation. That is its function in the architecture of the cosmos. It is not decorative, it is structural. It is the medium through which the universe maintains the isolation of its rarest and most complex structures. The darkness is why no signal from another civilization has ever been confirmed. The darkness is why no artifact from another world has ever been found. The darkness is why, despite 200 billion trillion stars in the observable universe, we have no evidence that anything is out there. Not because nothing is out there. Perhaps because the darkness between us and whatever is out there is so wide and so deep that signals weaken to nothing. Probes take longer than civilizations last, and light itself cannot cross the gap before the expansion of space stretches it into invisibility. The darkness is not empty, it is full of distance. And distance at cosmic scales is indistinguishable from silence. This is the deepest truth. The darkness of space is worse than you think because it is not what you think it is. It is not the absence of photons. It is not the visual quality of a black sky. It is not the aesthetic mood of a starry night. It is the physical manifestation of the universe's most fundamental property, that it is built around separation, that it distributes matter and energy so thinly across distances so extreme that the overwhelming majority of everything that exists will never interact with anything else. The islands of light and warmth and complexity, the places where stars burn and planets form, and chemistry becomes biology, are so rare and so scattered that the spaces between them are the defining feature of reality. You live on one of those islands. You were born on a planet orbiting a middle-aged star in a galaxy of hundreds of billions of stars, inside a cosmic web that stretches for billions of light years, during the brief era in which light still fills a meaningful fraction of the sky. You look up and see stars, and the stars make the universe look full. It is not full. It has never been full. The stars you see are the thinnest scattering of lanterns across the vastest darkness that physics permits. The Milky Way, the galaxy you call home, is almost entirely empty space. The local group, the cluster your galaxy belongs to, is almost entirely empty space. The cosmic web, the largest structure in the observable universe, is almost entirely void. And the voids are growing. The darkness of space is not a mystery. It is not a puzzle waiting for a clever explanation. It is an answer. It is the universe telling you, in the clearest possible language, what it is made of. It is made of distance. It is made of separation. It is made of the space between things. And the things themselves, the stars, the galaxies, the planets, the living beings looking up at the sky and wondering why it is so dark, are the rarest possible exception to a rule that applies everywhere else. The most unsettling truth is not simply that space is dark, it is that the darkness is the universe's honest face. When you see a photograph of a galaxy cluster, glowing and magnificent and apparently dense with light and structure, you're looking at a carefully cropped view of reality. Zoom out far enough and those clusters shrink to specks. The light they produce shrinks to nothing against the volume surrounding them. The darkness floods back in, overwhelming every luminous structure, reasserting itself as the dominant condition. The darkness does not surround the light. The light interrupts the darkness, briefly, locally, temporarily, and then the darkness resumes. Every star that has ever existed was a temporary interruption in a darkness that preceded it by billions of years and will outlast it by trillions more. Every galaxy that has ever formed was a brief clustering of matter in a void that will eventually reclaim the space it borrowed. Every civilization that has ever looked up at a night sky and seen stars was seeing the universe during its one slim window of luminosity. A window that is already closing, a window that will eventually shut, leaving behind a darkness so complete and so permanent that no future observer will ever know the light was there. You are inside that window right now. The stars are still burning. The galaxies are still visible. The cosmic web still holds together, thin and fraying at the edges, but still connected. The darkness has not yet won completely, but it is winning. It has always been winning. And the universe you see when you look up at the sky, the one that looks rich and full and decorated with light, is a universe in the late stages of a phase that will end. The darkness of space is worse than you think because it is not a backdrop. It is not a setting. It is not the empty stage on which the drama of stars and galaxies plays out. It is the drama. It is the main event. It is what the universe is doing with most of its volume, most of its energy, and most of its time. The stars are a sideshow, a brief, beautiful, vanishing sideshow that matters only to the things living in it. And the things living in it, the beings on the small warm worlds orbiting the scattered temporary fires, can look up at the darkness and understand, perhaps for the first time, what it is really telling them. Not that the universe is empty. Not that the night sky is black. Not that space is cold or hostile or frightening in the way a dark room is frightening. It is telling them that the universe is built around distance, that the warmth they feel is local, that the light they see is rare, that the connection they assume between the stars is an illusion of projection, and the true state of the cosmos is separation on a scale that makes every world where chemistry has been lucky enough to become biology an almost infinitely precious exception to a rule of darkness that governs everything else. The darkness of space is worse than you think because it is not just dark out there, it is dark almost everywhere. It has always been dark almost everywhere, and in the end, it will be dark everywhere, without exception, forever. The only thing standing against that darkness right now is the thin, temporary, impossibly rare light of stars. And one of those stars is yours. And the small world circling it, lit and warm and alive, is the single bright exception to the rule that defines the entire cosmos. The darkness is the rule. You are the exception. And now you know what the darkness is really made of.